Okay, so we will start with the lecture. So before we start, let me just have some discussion. So have you understood that points whatever we have covered up till now? Some of you might be irregular for initial lecture. Hmm? But whatever are the important points like ray theory of light, critical angle, acceptance angle, I have repeated. Hmm? Because that points are important, but probably now hereafter it is not possible for me to repeat it. So you please be regular so that because some students they have again changed that subject and all that things. Yes, coming. So hereafter at least you please be present at least for the initial lecture. Actually for all lectures you should be present. But if at initial lectures if you are absent, that will make your loss because you will not understand the concept and you will not get the interest. Okay. So I hope all of you are clear with the points whatever we have covered from first chapter. So online, is it clear? Those who are attending online, who is here? Vinal, Vinal Mohade, Shubham. Okay, so they are not responding. Is it clear whatever we have seen? So काय काय बघितलं आपण आतापर्यंत? Basically, in optical fiber, first point you have to understand. So lastly, in 5 minutes I will summarize and then we will start with the next numerical solving. Okay, so all of you are having calculators. Frequently I have told because the numericals are important for first chapter. So please at least 2 in 1 it is there or not. Have calci, otherwise it is not possible to carry the numericals. And if the theory sobat thus numerical solve केले तर that will have some relation. No? Otherwise after 2 days if I ask you to solve numerical, that is problematic. So we have seen basically optical fiber is main communication channel when we transmit the information in the form of light. Whatever we have seen in analog communication, digital communication, in that both communication the information was transmitted in the form of electrical signal. But whereas in optical communication the information is transmitted in the form of light. That is basic thing you have to understand. Then optical fiber consists of two main layers. What is that? Which two main elements are present in optical fiber? Core and cladding. So core is the basic inner part and that is surrounded by the cladding. And all the light propagation takes place through the core only. Okay, so these diagrams I have shown to you. See here. Core and cladding. So this is side view. Front view जर बघितले आपण तर you will observe just two circles. Okay. So similar picture frequently I have told you. Same example. Structure of our pen. So that refill it is acting as core and it is surrounded by cladding. And apart from that, when we are using it for practical applications, number of protective layers are used based on where you are going to use that. Suppose in our infrastructure, when it is packed, there you are going to use the optical fiber cable. That may not require protective, more layer of protective coatings. But when you observe the applications of optical fiber or telephone network, with the long distance वरती तुम्हाला transmission करायचं असतं. At that time, you require the more protective layers for the optical fiber. Okay, that's why if you see the pictures of optical fiber cable, जर तुम्ही बघितले तर काही मध्ये फक्त कोर आणि क्लॅडिंग असतं. And in practical application, if you see that cables are having the protective layers. So this one core surrounded by cladding, then primary buffer is there and it is surrounded by some outer sheet. So why I am repeating it? Because in the previous syllabus there was one chapter optical cable design. म्हणजे फक्त optical ऑटोमॅटिकली वापरू शकत नाही कोर आणि क्लॅडिंग. दॅट इज डेलिकेट. यू नीड टू सराउंड इट विथ सम अदर प्रोटेक्टिव्ह layers of cables. आणि तुम्ही जर व्हिज्युअली बघितलं तर यू विल नॉट ऑब्झर्व एनी डिफरन्स इन द रेग्युलर फायबर अँड म्हणजे रेग्युलर फायबर केबल. सो व्हेन देयर विल बी प्रॅक्टिकल्स आय विल शो दॅट ऑप्टिकल फायबर केबल इन द लॅब. व्हिज्युअली जर बघितलं तर तुम्हाला डोळ्याला काही दोन्हीमध्ये डिफरन्स दिसत नाही, फक्त लाईट असते. दॅट इज देअर. सो बेस्ड ऑन द ऍप्लिकेशन these protective layers are decided. Okay, so that is the basic things. बघा आता इथं दाखवलंय कोर आहे, क्लॅडिंग आहे आणि 4-5 प्रोटेक्टिव्ह लेयर्स इथं दाखवलंय. हिअर इफ यू सी व्हिज्युअली तुम्हाला आपली साधी वायर वाटते डोळ्यांना बघितलं तर, बट इनर साइड इट इज हॅव्हिंग द ऑप्टिकल फायबर कोर. ओके, so these things you should understand. Then another basic thing we have seen that in optical fiber the basic block diagram, that is also very important. So in block diagram we have seen for any communication system which basic blocks are important. कुठले बेसिक ब्लॉक असतात कुठल्याही कम्युनिकेशन सिस्टम मध्ये सांगा मला. Very simple question I have asked. Tell me. Transmitter and receiver. Okay, and channel. Transmitter, receiver, and the channel. These 3 blocks are mandatory for any communication system. Then, when we say the optical communication system, so already I have shown you this block diagram. Which 2 elements are required in between for optical communication system? What are the blocks? कुठले ब्लॉक आहेत सांगा ऑप्टिकल कम्युनिकेशन सिस्टम मध्ये. इन्फॉर्मेशन सोर्स फर्स्ट. देन आय हॅड आस्क्ड यू टू ड्रॉ दैट डायग्राम. असं तुमच्या नोटबुक मध्ये बघा. This is the last time I am revising basic points, and hereafter we will continue with the next points. See, this is the diagram. Information source, irregular communication systems are and this is optical. Information source, electrical transmit means modulator or some other processing circuit. Basic information signal that is made in more suitable form in this electrical transmit section. Then next, optical source. Optical source will convert what? हा इलेक्ट्रिकल सिग्नल आहे तो ट्रान्समिट करायचा आहे. बट ऑप्टिकल फायबर कॅन, वन मोर थिंग यू कीप इन माइंड, ऑप्टिकल फायबर accepts the signal only in the form of light. So if you directly give some function generators output to the optical fiber, it will not able to pass that signal. So it accepts the signal only in the form of light. That's why here in between this optical source is mandatory. This is converting the electrical signal in the form of light, and then it is given to the optical fiber cable. Then next, its output is given to optical detector. Optical detector चा काय function है? It is converting again the light into form of electrical signal, and then it is again given to the electrical receiver, that is demodulator, and then it is given to the destination. Okay. So this is the block diagram that you should understand. Then next points we have seen here, basic working principle of this optical fiber is based on which point? Total internal reflection. This is very basic point. जेव्हा एखाद्या मीडियम मध्ये लाईट इन्सिडेंट होते तेव्हा त्याच्यामध्ये 3 केसेस होऊ शकतात. Either some amount of light, समजा ते हे टेबल वरती, consider this table surface. Suppose the light ray is incident here, so some amount of light will be absorbed by the table itself, some will be passed through this side, and some can be reflected back. That is basic concept shown here. But as I told you, for these basic points you refer the diagrams from notes only, because that I have considered from book. PPT PPT मध्ये नोटेशन किंवा डायरेक्शन काही केस मध्ये वेगळे असू शकतात. सो इन ऑप्टिकल फायबर when the light is passing, it should pass only through the core and it should not enter into the cladding part. That is basic thing you have to remember. And if you don't apply any condition, that will not happen. Total internal reflection म्हणजे काय? core cladding interface आहे. त्याच्यावरती लाईट कोर मधून क्लॅडिंग मध्ये जायला पाहिजे का ऑप्टिकल फायबर मध्ये, सांगा मला. These are very basic things. Whether the light is or whether the light should go from core into cladding. No. कोर मधून ती कोर मध्येच पुढं ट्रान्सफर करायला पाहिजे. म्हणजे सपोज आता हा पेन आहे सांगितलं मी, इथं लाईट रे आलाय, रिफिल आणि वरचा सरफेस, त्याला काय म्हणणार आपण? कोर क्लॅडिंग इंटरफेस. मग इथून रे गेला की परत तो कोर मध्येच यायला पाहिजे. जर क्लॅडिंग मध्ये गेला तर त्याला आपण रिफ्रॅक्शन म्हणतो. जर कोर मध्येच परत आला तर काय म्हणतो? त्याला रिफ्लेक्शन म्हणतो. मग त्याच्यासाठी इथं रे theory of transmission, that point we have seen. So in ray theory of transmission there are three cases that we have discussed. First case is simple refraction. If you don't apply any condition, refraction will take place. That is natural tendency. तुम्हाला फिजिक्स मध्ये वगैरे झालं असेल बघा. पाण्यात if you have that ray of light incident in the water, that path it is changing. Okay, म्हणजे नॅचरल फेनॉमेनॉन कुठला आहे जो अपर होतो जर आपण काही कंडिशन अप्लाय नाही केला तर? दॅट इज रिफ्रॅक्शन. But as we want the total internal reflection, we have to apply some condition. Otherwise, it will not happen. So first condition we have seen, N1 should be greater than N2. Refractive index of core should be greater than refractive index of cladding. Why? Because here if you see, this is N1, this is N2. Light ray is incident at this core cladding interface, and it is making angle of incidence as phi1, and here it is refracted at angle of phi2. So here, if you apply the Snell's law, N1 sin phi1 is equal to N2 sin phi2. So by using that law, जर इथं angle of refraction जास्त पाहिजे असेल तर ह्या मीडियाचा रिफ्रॅक्टिव्ह इंडेक्स काय पाहिजे? सेकंड मीडियाचा कमी पाहिजे. त्या लॉ वरून लक्षात ठेवा तुम्ही, N1 sin phi1 is equal to N2 sin phi2 means ज्या मीडियाचा रिफ्रॅक्टिव्ह इंडेक्स जास्त असतो तिथला अँगल ऑफ इन्सिडन्स काय किंवा तिथला अँगल काय असतो? कमी असतो. सो हियर फर्स्ट केस इट इज शोन, simple ray is incident with angle phi1. It is refracted with angle phi2. This is incident ray, this is exit ray. As we go on, suppose हा 30 असेल तर हा 40 असेल. हा 40 केला तर हा काय होणार? 50 होणार. If you increase it as 60, this will again go on increasing, and at one condition it is coming along the core cladding interface. So that is condition where the angle of refraction is how much? Core cladding interface less तो जातो along that core cladding interface. Means what is the angle of refraction there? Zero कसं होईल? Angle of incidence कसा मेजर करतो आपण? ज्या पॉइंटला हा रे इन्सिडेंट झालाय, you draw one normal here. आणि ह्याच्याशी with respect to this angle of incidence, इथून इकडे आहे तो angle of refraction. मग जर हा इथून इथं इन्सिडेंट झालाय आणि इकडं हा रिफ्रॅक्ट होतोय तर ह्या दोन मधला अँगल आपण मोजणार ना. ही झाली नॉर्मल लाईन, हा झाला त्याचा रिफ्रॅक्टेड वेचा पाथ. हा अँगल ऑफ रिफ्रॅक्शन किती येणार इथं? इट विल बी 90 degree. Okay, and that angle of incidence for which angle of refraction is 90 degree, that is called as critical angle. So second case is of critical angle. First आहे ती रिफ्रॅक्शन ची आहे, सेकंड आहे ती क्रिटिकल अँगल, आणि थर्ड वन if it is 80, for this it will be 90. हा जर मी 80 पेक्षा जास्त केला, हा काय होतंय? जसं जसं इकडचा अँगल इकडे वाढेल तसा तो it is coming close towards the core part. हा जर अँगल ऑफ इन्सिडन्स मी क्रिटिकल अँगल पेक्षा जास्त केला तर काय होईल? आधी हा इकडे इकडे येत होता. सेकंड केस मध्ये तो कोर क्लॅडिंग इंटरफेस वरून along that only it has passed. In third case what will happen? It will come again into core. 90 पेक्षा जास्त होणार ना तो. आधी 40 असेल, 50 असेल, 60, 90. परत काय होईल? It will become more than 90. Means again it is coming back in which area? Core or cladding? Core. Means whatever way it is incident, no any amount of that light has been transmitted in the cladding, whereas it has totally internally reflected in the core. And that total internal reflection is the main basic point in the working of optical fiber. मग दोन कंडिशन आपण बघितल्या. N1 should be greater than N2. Second case, angle of incidence at core cladding interface should be what? Greater than critical angle or less than critical angle? हा क्रिटिकल अँगल पेक्षा कमी असेल तर तो क्लॅडिंग मध्ये जाणार. हा क्रिटिकल अँगल एवढा असेल तर तो कुठे जाणार? कोर क्लॅडिंग बाउंड्रीला. आणि जर तो क्रिटिकल अँगल पेक्षा जास्त असेल तर कुठे येईल तो? परत कोर मध्ये. Means to have the total internal reflection, it must be greater than the critical angle. So this third case is shown. Total internal reflection होते बघा इथे. Okay. So like this we have to consider. Is it clear? Ray theory of light. आणि अजून एक कन्सेप्ट आपण याच्यामध्ये बघितलं होता, acceptance angle. And one more formula you have to remember here. Sin phi c is equal to N2 by N1. कारण इथं काय होणार? स्नेल्स लॉ अप्लाय केला. N1 sin phi 1 is equal to N2 sin phi 2. But what is the phi 2 value here? 90. Sin 90 is equal to 1. So phi c is equal to sin inverse of N2 by N1. That formula you write down somewhere. Initially also I have told. These are the important formula for solving the numerical. Critical angle phi c is equal to, and all of you should have separate notebook. Have you made? Can I check in last 5 minutes? So at least here after you note down the things. Phi c is equal to sin inverse of N2 by N1. Okay, that is the concept of critical angle. Okay, so clear? Written that? Written? Okay. Understood? Then next is the transmission of light in a perfect optical fiber. मग हे डायग्राम शेवटी दाखवले बघा. इथे लाईट रे आला, इथं हा क्रिटिकल अँगल पेक्षा जास्त अँगल इन्सिडेंट झाला. सो अगेन इट इज कमिंग इनटू कोर. नेक्स्ट इट इज अगेन ट्रॅव्हलिंग आणि परत बॉटम साइडला पण कोर क्लॅडिंग इंटरफेस असणार आहे. इन ईच फायबर remember there will be two core cladding interface. One is at the upper side and another it is at the lower side. Okay, so here also it is coming again, making angle more than critical angle and coming here back. So this is the transmission of light ray in perfect optical fiber. Okay, so next angle we have seen acceptance angle. Okay, so now that concept I will not repeat whole, just understand. इथं कोर क्लॅडिंग इंटरफेसला इन्सिडेंट व्हायच्या आधी हा लाईट रे पहिल्यांदा कुठे इन्सिडेंट होतो? कोर ऍक्सिस वरती. and it is making some angle with respect to that core axis, and this angle is deciding ultimately what will be the angle of incidence at core cladding interface. That's why Within this acceptance cone, if light is incident, then only ही पुढची condition काय होते satisfy होते. If light ray is incident outside the acceptance cone, this next condition will not be satisfied and you will not be able to get the total internal reflection. So, three conditions you have to understand for total internal reflection. First, N1 should be greater than N2. That is first condition. Then, angle of incidence at core cladding interface should be greater than or less than critical angle. Greater than critical angle. And third one, angle of incident ray with core axis. Incident ray चा core axis सोबतचा angle जो आहे, that should be less than acceptance angle or more than acceptance angle. That should be less than acceptance angle. That's why you remember the hint. Whenever you are going to calculate these angles in the numerical, always critical angle ची value ही 70-80 पेक्षा जास्त येते, पण ती 90 पेक्षा नेहमी कमी येते. It will not be greater than 90 anytime. So you can write down these hints just for cross-checking your numericals. Always the critical angle is around 70 degree, 80 degree, like that. Higher value असते critical angle ची. And if you see the acceptance angle, it will be less than 30, like 30, 20, 70, like that. कारण हा acceptance कोण आपला कमी आहे. So these concepts we have seen, and after that we have seen the numerical aperture derivation. Numerical aperture is also one important parameter of optical fiber, and it is deciding the light collecting ability of optical fiber. Because in the diagram we have seen, see, this is optical source. This will emit some light, and in front of this optical source only we are going to use the optical fiber cable. Always the optical source is having optical fiber cable in its next block, and this is called as coupling of source and fiber, because we are making the arrangement proper such that light should be absorbed by the fiber. Okay, त्याला आपण alignment सुद्धा म्हणू शकतो. For example, okay, you just give me one pen. बघा, suppose you consider this is optical source and this one is optical fiber. So how will be the arrangement? Like this only it will be in any diagram. मग इथं मागं कुठलेही ब्लॉक असू दे, that is additional part, but always in the practical application you have to couple optical source with optical fiber, and while you are going to couple this, the alignment should be proper. Our intention is whatever light is emitted by this optical source, all that should be absorbed by the optical fiber, otherwise that is considered as loss. So this fiber should have maximum light collecting ability, that is called as numerical aperture. मग जसा N1 आहे, N2 आहे, critical angle आहे, acceptance angle आहे, as per that all parameters, this numerical aperture is very important parameter of optical fiber. So when you are going to select any fiber, you have to check what is its numerical aperture value. जसं तुम्ही capacitor चे parameter असतात, voltage rating is there, current rating is there, power supply किती maximum आहे, किंवा resistor चे सुद्धा parameter असतात. तसं optical fiber select करताना तुम्ही numerical aperture ची value त्याची check केली पाहिजे. Suppose two fibers are there, one is having less numerical aperture and another is having more numerical aperture. Obviously which one you will select? एकाचा समजा 0.2 आहे आणि एकाचा 0.5 आहे. 0.5, because you want maximum amount of light should be collected by the fiber. So that is the concept of this numerical aperture, and its formula is given by, so numerical aperture is noted by the symbol as capital NA, and its formula is given as, so it is there last. बघा इथं दिलेलं फॉर्म्युला आपण बघितले ते डेरिवेशन. If not understood, you go through that. So Na is equal to n0 sin theta a. N0 means refractive index of air, that is equal to 1. Theta a means acceptance angle. n1 square minus n2 square raised to 1 half. मग न्यूमरिकल मध्ये दिलेलं असतं n0 ची व्हॅल्यू ही बाय डिफॉल्ट 1 अज्युम करायची as far as the condition is not specifically given, like fiber is kept in the water or like that. So acceptance angle is given, n1 is given, you will be asked to calculate n2 value. Like that numericals you have to solve. Okay, and Na is equal to n0 sin theta a. N0 is equal to 1. So this formula also you have to use, or also you can write Na is equal to n1 square minus n2 square raised to 1 half. कुठल्याही टर्म मध्ये तुम्हाला तो फॉर्म्युला यूज करता यायला पाहिजे. Okay, so this is the derivation for numerical aperture. So derivation I will not repeat. If any problem you can ask me later. Okay, then Na चा हा एक फॉर्म बघितला आपण. Another form of Na formula in terms of this delta that we have to see. Delta means what? That is also one performance parameter of optical fiber. Delta हा जनरली डिफरन्स साठी आपण यूज करतो वर्ड सिंबल. So delta is relative refractive index difference between core and cladding refractive index. Core आणि cladding मध्ये refractive index मध्ये किती डिफरन्स आहे, that is noted by the symbol as delta. Okay, so always the difference between n1 and n2 is very slightly different. खूप जास्त डिफरन्स नसतो. Like n1 is 1.48, n2 will be 1.45, 1.42. So that is delta, and delta चा हा स्टँडर्ड फॉर्म्युला आहे. What is formula for delta? n1 square minus n2 square divided by 2n1 square. So if you simplify this, what value you will get for n1 square minus n2 square? 2 delta n1 square. And then numerical aperture. हा जो आपण फॉर्म्युला बघितलाय न्यूमरिकल अपर्चरचा, Na is equal to n1 square minus n2 square raised to 1 half. मग इथं तुम्ही n1 square minus n2 square ला ह्या टर्मनी कुठल्या ह्या टर्मनी रिप्लेस करू शकता. सो हियर यू कॅन राइट n1 square minus n2 square च्या ऐवजी काय घ्या तुम्ही 2 delta here 2n1 square into delta and bracket raised to 1 half. आता n1 square raised to 1 half म्हणजे काय राहील फक्त n1. So n1 will remain outside and in bracket what will remain? 2 delta raised to 1 half. Okay, so this is the formula for numerical aperture. Yes, any doubt? Clear? So this formula also you have to use in the numerical. आणि हे जे दिलेलं आहे ह्याच्या पुढे is approximately equal to n1 minus n2 divided by n1. कारण ज्या अर्थी n1 आणि n2 मध्ये खूप कमी डिफरन्स आहे त्या अर्थी this term you can equivalently consider to this also. So this is just additional part given. Right now you cannot if you don't focus on that, that is okay. जेव्हा आपल्याला गरज लागेल तेव्हा हा फॉर्म्युला आपण रेफर करू. सध्या आपल्याला फक्त एवढाच करायचं. मग एनएचं इक्वेशन इथं आपल्याला मिळालं. इथपर्यंत आपण पार्ट बघितलेला आतापर्यंत. सो आय होप ऑल ऑफ यू आर क्लिअर नाउ. And hereafter I am not going to repeat. If any doubt you are having, personally we can discuss. Okay, because syllabus is also lagging in that case. बघा आता न्यूमरिकल्स आपण सॉल्व करूया. For today's lecture I will just explain you the numericals calculation, but for next lecture you must have calculator with you. Okay, otherwise just reading the numerical, that is not of use. Wait 1 minute. Let me check some simple numericals first. All of you are using the study material. Okay, see here. Here one numerical is I will read the numerical first. Try to understand what is given, what is asked. A silica optical fiber with core diameter large enough to be considered by ray theory. आता हे फक्त ऍडिशनल इन्फॉर्मेशन दिलेले आहे की त्याचा डायमीटर सफिशियंट आहे फॉर रे थिअरी ऑफ लाईट. ते आपण आता फायबरचे टाइप बघू तेव्हा तुम्हाला कळेल की सिंगल मोड फायबर मध्ये डायमीटर कमी असतो, मल्टी मोड फायबर मध्ये डायमीटर जास्त असतो. So that we will see later on, but along with this ray theory of light, first we will see the numericals. So it is enough to be considered by ray theory analysis as core refractive index of 1.50. N1 is given as 1.50. Then refractive index of cladding is 1.47. So N2 is given as 1.47. Determine first critical angle. It is asked to calculate the critical angle at the core cladding interface. Then NA for the fiber, numerical aperture of the optical fiber, and third one it is acceptance angle. Okay, so I think you have calculator on your mobile, no? You can use that. So you can just write down this numerical. Don't write all that sentences, at least symbols you can write. Write down. N1 is equal to 1.50. N1 is equal to 1.50. N2 is equal to 1.57. Anybody is there? Okay, so there is one session, TNP session. You just note down this numerical. N1 is given as 1.50, N2 is 1.47, and asked to calculate critical angle, numerical aperture, and acceptance angle. And try to solve it by your own. Those who are attending online, please type your number in the chat box fast. आता जो ऑनलाइन आहे त्यांचं कसं तुम्हाला सेशन आहे की डायरेक्ट? Okay, so there is session, offline session is there. So there is no any link on the group. So lecture we will stop here.